Hey guys, how's it going? So this is going to be a short video, but I did want to focus on connectivity piece for this GaN and silicon carbide designs. I've been getting a lot of requests in terms of talking about how to best make the measurements and all that, how to lay out the board properly, what are the best connections to use and so on. So I wanted to quickly make a comparison video showing you how laying out as well as the connections you use makes a huge difference, such a big difference. Okay, so what we'll do is we'll keep the setup exactly the same, we'll use the same equipment, all we'll change is the different connections, right? So for example, the board we have right now has this pigtail connections, sort of long cable, and we'll change it to shorter, so you right. So just to kind of give you a brief, so this is the GaN board I've been using. This is the half bridge. We are looking at the high side VGS measurement and the VDS measurement, so you can expect what a VGS measurement looks like. And then there's the low side. We are not testing that right now, but what I have here is the Tektronix TIVH probe. So this is the 800 megahertz probe, and we are using the 50x tip, right? All right, so pigtails, nice long ones, right? And there is your measurement. Take a look at that. it's pretty bad, right? So now what I'll do is I'll just imagine a lot of cables on this, right? So I obviously have just one probe connected to it, nothing else. But what I'll do is I'll just move this along and just see what happens, right? So take a look at that. Now obviously a lot of you will be like, come on, you shouldn't be doing that, right? You should be wrapping them around, having them in a nice twist. So let's try that, right? So give me a second, I'll set this up and we'll do a twist. Okay, all right, so I twisted them as best as I could, I guess, and let's look at if it makes any difference to the signal. So I'll turn this board on and we'll look at the signal. Right, so a little nicer, I guess, right? It still kind of affects, so I'm just moving this, I'm just kind of playing with it a little bit, right? And you see it significantly changes how it looks on the scope, right? Now what we'll do is we'll get rid of that long cable and use a shorter one and see if that makes a difference. Okay, so give me a second. All right, so I got a much shorter cable. So this is similar cable but much shorter, right? So this is the one I was using earlier, which kind of I wanted to show you how those traditional differential probes will act. This is a significantly shorter cable. I think it's like 2 inches or probably less than that, right? And let's look at the signal and see what it does, right? So let me turn on the board and let's look at the VGS signal. Oh, much nicer. Take a look at that, right? So obviously that helps quite a bit. So that gives you something to go after. You almost start seeing the Miller plateau, right? So that's pretty nice. But still there is some ringing, right? So let's switch to no cables and see what happens. Okay. All right, so I essentially removed this cable, or I guess this cable, the shorter one, right, and went directly on the board. So this is an adapter that converts this MMCX connector, the shielded one, and takes it to. So it's pretty good actually, especially if you're using a square pin. And see how the signal looks now, right? So here you go. We'll turn on the circuit first. So let me turn this on. Let's go on, and there you go. Nice, pretty darn good actually. So let's see if I can scale it. All right, there you go. So you can see the Miller plateau, it kind of rises. It's pretty decent. This is pretty decent, right? So you can actually put cursors on it. Let's take a look at the turn on time. Now you almost start seeing stuff, right? So let's start the cursor, put them on right here. All right, so take a look at that. So about 9.6 nanoseconds is what it tells me. Pretty fast, right? And if I go even further, because you need to see the Miller plateau, I can probably go even closer in, which is essentially right here. And then you can see about 1.82 nanoseconds. Yeah, I mean this is pretty good. Yeah, so this is pretty good. It does give you much better results than using any of these cables. Especially when even winding the cables doesn't give you as much. Now let's try this with just the MMCX connector and see if that makes a difference. What I'll do is I'll switch to this circuit. They're exactly the same circuits. One of them has this MMCX connectors which are completely shielded to the ground, whereas this one is more of a square pin, which is more convenient, I guess, right? So all right, let's switch and see what happens. All right, so I got rid of this adapter right here. So this is a MMCX connector to a square pin adapter, which we are using for the square pins, right? And we are connected directly to an MMCX connector, which should in theory give us the best possible connection, because the connection is completely shielded. It's extremely high bandwidth connector, right? And let's see what happens now, right? So we'll turn this thing on and see how the gate signal looks. All right, take a look at that. That's pretty darn good, right? So take a look at that, right? So you can actually see the Miller plateau really nicely. I'll change the cursor so you can see the cursors. 1.82 nanoseconds, so that's very close to what we had with the square pin adapter. And then if I go right here, look at this, there you have it, right? So square pin did have a little more artifacts than this one does, but you can see, I mean, this is pretty nice. So obviously, in conclusion, I mean, this is nothing. This is not rocket science. I mean, we have known this. I just wanted to try it to see if it makes a difference. Hopefully this was useful. If you have any questions, let me know, and I'll do another video to capture your thoughts. Right? Thank you. Until next time. Bye.